Okay, so this is a Heisenberg uncertainty question, right? So the one we're going to use here is ET is greater than or equal to Planck's constant over 4 pi. Or just h bar over 2, but anyway, that's all right. And so we just need to solve this, right? So the uncertainty of the energy, and this is the energy that we need to borrow, right? Okay, times 1.14 times 10 to the minus 23. That's seconds, right? Is equal to 6.63 joules times 10 to the minus 34th joule seconds. I just made Planck's constant somewhat larger than it should be, almost, divided by 4 pi, right? All right, and then we just have to solve for that energy, and that's going to be joules, of course, right? So 6.63 times 10 to the minus 34th divided by 4 divided by pi. I'm also going to divide by the 1.14, right? 14 times 10 to the minus 23rd. And I get that the amount of energy in joules is 4.628 10 to the minus 12th joules, which is a handsome amount of energy, right? Let's divide by 1.6 times 10 to the minus 19th. This will turn it into electron volts, right? And then I'm going to divide by 1 times 10 to the 6th to turn it into... I suppose you could just divide by 1.6 times 10 to the minus 13th, but you know, there's some suspense here, you know. Okay. So I'm going to divide by 1 times 10 to the 6th, and I get 28.925, and this says 29.0, so yeah, I don't know why it's slightly different. Maybe I used a different version of the... All right, what do we got here? My little laptop here is preparing for takeoff. Make sure your seat backs are in the full upright position. Your tray tables are stowed. Yeah, that's right. Yeah, I don't see. I don't know why it says 29. I get 28.925 MeV, right? Okay. So we're talking. Really, what we're talking about here is that's the energy it needs to tunnel. I'm going to put tunnel. Okay. I'm going to put tunnel in tunnel. That's how you spell tunnel. Sorry. I think I like the LE though, you know. Okay. That's the energy it needs to tunnel through the potential barrier, right? It's bound in the electron. It has to violate conservation of energy to actually escape. Okay.